Today we are discussing about the computer architectures. Okay. So first of all, I will tell you the basic computer, microcomputer structure and operation. Computer have the three components, microprocessor. So microprocessor is the digital system. Tell me, sir, no? Microprocessor what? Digital system. Digital system contain the digital circuit. So microprocessor contain the digital circuits are what? ALU, control it, register. So microprocessor is a semiconductor device manufactured by various technology which contain the ALU, control it, register. Nowadays cache memory also. Okay, no, on the cache memory fastest memory only. Nowadays, okay, latest microprocessor. The microprocessor, no, is IC, integrated circuit. Is IC, no? IC integrated circuit. So computer contain the processor. Okay, next important element is the, so memory. Okay, so memory contain the memory locations. Okay, so every memory contain the memory location. Okay, so the how many number of location that depending on the memory capacity. The memory look like that. Okay, memory always represent the primary memory only, RAM or ROM. Memory nothing but not secondary. Okay, is a RAM or ROM. Your laptop DRAM or something. Okay, RAM or ROM. Okay, memory representation always only. Wherever the memory is a word. Okay, so computer contain the processor and memory, and another thing is what I mean? Peripherals. Peripherals. Okay, IO, input and output peripherals. IO also contain the same like a memory. Okay, so how memory look like that? No, IO also similar. Okay, so memory contain the memory location. Okay, similarly IO also. How many number of memory location? That is a memory capacity. 1 kilo memory, 1 kilo location. IO all the same only. How many number of IOs are there? Okay, keyboard, mouse, touch screen. How many number of IOs are there? The number of locations are there only. Keyboard have one location, mouse have one location. It's all peripheral locations now. The peripheral address now. Whatever no, you mentioned this number. Okay, for example, 0, 1. This is the address of the one peripheral. The address of the one peripheral. Okay, so every peripheral have some address is there now. They call peripheral addresses now. Okay, some number. Okay, no, up to whatever. Okay, they call no peripheral address now. IO address or peripheral address now. Okay. So the memory contain the memory location. Okay, so memory location. Each memory location. Okay, each memory location have some address now. Address. Okay, so this address is called what? Memory address. The address called a memory address. The peripheral address only. Peripheral address or IO address now. Okay. Actually, but device like that. For example, my device, the devices now. The devices. A keyboard only now. Keyboard. Keyboard, okay. Keyboard is a device. No, have some address is there now. Some address. Okay. Mouse is a device. We have some address is there only. Some address now. Printer is a device. Monitor is a device. Audio is a device. Every device, no. Yeah, device look like no. So keyboard, every device look like some mechanical components. No. Device, no. Front end, no. Device, no. Keyboard, no. Keys are there. Mouse, some buttons are there. The back end contain the electronic circuit. Okay. Front end look like a mostly mechanical component. Printer is a what? Everything motors are some front end device. Okay. But back end contain electronic system. Okay. Every device front end look like a some electronic mechanical integration is there. Front end. Okay. Then a device. But back end contain some the electronic circuit. The circuit it can store some kind of the information that is called address. Okay, where you can store on it. Okay, the address provided by the manufacturer. Okay, your Dell manufacturer, Dell, whatever your hardware, no, the manufacturer provide the where you can store the information. No, that is called IO address on it. Okay, the microprocessor, the logic simple actually. The microprocessor, what is the way to communicate the memory? Exactly the same way to communicate the device also. No difference at all. Microprocessor point of view, either IO also, memory also, same kind of treatment. Microprocessor, there no sense about like this is a device, this is a memory, nothing. Microprocessor behavior is the same. Okay, how to communicate the memory, how to communicate the IO, similar kind of concept. So what happened? Tell me. Microprocessor to communicate the memory. Microprocessor should know the memory address. Microprocessor should communicate the mouse or keyboard. Microprocessor should know the what? Peripheral address. The only address should know. Okay, the IO here, memory layer, like that. Then one micro start communicating. So computer have three components. Okay, IO, microprocessor, okay, memory. Three components are there. Fine. So the microprocessor mainly perform four operation. Okay, microprocessor mainly perform four operation. First operation is called a memory read operation. Memory read. So the meaning of memory read, microprocessor to communicate the any memory address, okay, anything randomly, some address, okay, any address, here reading now. Read now. Yeah, reading the operation. Okay. The arrow mark indicate data transfer from memory to processor. Memory have some information in there, no, the reading, okay. Okay. So I think these are called register. You don't understand now? Okay. What happened to the, no, the read from the register. Read from the exactly same. Read from the register. Is a register only. Every memory location contain the register. The data transfer from memory to processor, nothing but read from the register. Understand? No? The meaning of memory read operation simple. Microprocessor read from the register. Okay. Okay. So the meaning of memory read nothing but data transfer. Okay. Data transfer from memory to processor. Correct? No? Data transfer from what? Memory to microprocessor. Memory to microprocessor. So read data from the micro memory. Okay. What is memory write? What is memory write? Write data into what? Memory. Okay. Read data from memory. Okay. Microprocessor read data from memory. Microprocessor write data into memory. Okay. Memory read operation. Write operation this symbol. Write operation arrow mark na. What the write operation? Microprocessor write into the register. Microprocessor write into the what? Register. Microprocessor write into the memory nothing but write into the register only. Okay. Into the memory location or memory location. So every memory has some location, address, memory location. Okay. So every register has some address is there, some address, no. So the operation is called what? Memory read. The operation called what? Memory write. Similarly, the IO also. In case input device is there, keyboard input device. Read from the device. Okay. IO read. Okay. The meaning of IO read, third operation. Accept data, microprocessor accept data from input device. Microprocessor accept data from input device. The meaning of the IOR, I'm telling IOR. So keyboard is the input device. Accept the data from the input device. Microprocessor communicate the input device reading also. IO read. Data transfer from the input device to microprocessor. Data transfer from where? Input device to what? Microprocessor. What IO write? Third operation. IOW. What IO write? IO write is nothing but output device. Okay, printer. Output device. Okay. So which operation this can call? IOW. What are IOW? Yeah. Sends data. Okay. Sends data into which device? Output device. Any output device actually, whatever. LED, printer, monitor, whatever. Okay. So the data transfer to what? Microprocessor to tell me. Output device. Okay. First one is the data transfer from the memory to processor. Memory to processor. Second one is a what? Microprocessor to tell me memory. So four operations microprocessor perform. Just I told you, four operations only. Any microprocessor, whatever, maybe that is Intel, ARM, whatever. Okay. I'm telling you generic. Okay. Any processor basically perform how many operations? Four. So memory read operation, memory write operation, IO read operation, IO write operation. So microprocessor prints some information, then IO write operation. Microprocessor reads something, the programmer decide. That's why your program, assembly language program, write a program. Programmer, you decide when you are going to communicate a printer. Okay, I want communicate a printer, now perform IO write operation. I want read something in the memory. Okay, I want write something in the memory. Okay, then what? Memory read operation or memory write operation. So microprocessor mainly perform the 4 operations now. The 4 perform on now. Memory read, memory write, IO read, IO write. But how to perform this operation? We are going to discuss more detail. Okay, now you can see now how the things perform. So your people observe the every memory, you can see any kind of the memory can observe. Every memory internally contain the decoder. Every memory internally contain the what? Decoder, no? Decoder. So decoder input is the address lines. Okay, for example, the 2x4 decoder. 2x4 decoder, how many inputs are there? 2. How many outputs? 4. So the 2 inputs are address lines only. Address lines are symbols are A0 and what? A1. The output now is a memory. So how many memory locations are there? How many? 4. This memory depth only 4 only. If you are going to the 4 memory locations are there, first memory location address what? 0, 0. Second memory address what? 0, 1. Next one 1, 0. Next one 1, 1. Okay. Whenever the memory contain the 4 location, so address lines are decided. Okay, where to communicate. Okay. For example, first memory location to communicate what A0, A1, 0, 0. The first one to correct in also. Whenever A0, A1, 0, 1, communicate the what? Second one. A0, A1, 1, 0, communicate the what? Third one. A0, A1, 1, 1, communicate which one? Fourth one. Like that. So the similarly now the decoder compulsory. Okay. But decoder how many number of inputs? Okay. The decoder how many number of inputs? Definitely that depends on the what? Depth of the memory. The memory height. Okay. Height of the memory decide on. The memory capacity decide on. For example, so actually the decoder input is coming from the microprocessor. So microprocessor manufacturing time they are decided now. Okay, how much memory to communicate on. In case your people taken the 8085 microprocessor. 8085 microprocessor 16 address lines are there on it. 16 address lines are there. 8085 microprocessors on it. 16 address lines are there. Okay, decoder input 16 address lines na A0 to A15. 16 address lines only. Decoder input no 16. Decoder output. Decoder output what? Decoder input 16. Decoder output tell me. Hello. 2 power 16. Decoder output 2 power 16. Inputs are how many? A0 to what? A15. Decoder output how many? Tell me. 2 power 16. 2 power 16 approximately tell me.
65.
Yeah. Approximately.
65536.
If you exactly 65,536 approximately. Yeah, I told you 2 power 16, but 2 power 10 into 2 power 6 or not? 2 power 6 is what? 64. Approximately 64. 2 power 10 is what? Kilo. 64 kilo. 64 kilo. 64 kilo. Then approximately tell him 64 kilo. Exactly 65,536 now. Okay, the depth of the memory now. So 8085 microprocessor point of view, it can support memory up to 64 kilo. Up to nowadays, your people are with the the 4 GB or 8 GB, 16 GB RAM only. I'm telling the old 8085. Support no the up to na 64 kilo support now address lines. And the memory depth depth decide the address lines only. And similarly, the data, okay, every location contains some data, na? The register size only. The size of the register is 8 bit. What the register size? 8 bit. Width of the memory 8 bits only. 8 bits only. Okay, now you can see. Yeah, you communicate the microprocessor. So this is called a data bus. The first one called a address bus. Okay, this one called a address bus now. bus is a group of wires. 8085 point of view, 16 wires are there. Yeah. 16 wires are there, no? 16 wires. I put the direction like that, 16 wires are there, okay? So decoder input A0 to A15, 16 wires are there. So the address bus. So why the name address bus? Yeah, with help of this bus, find out the address of the memory.
Locations.
Memory contain the what? Location. Each location have one address. The address identification with what? Address bus. Why you can call this data bus?
To transfer the data.
Once to identify the address, next what? We are reading from the register. Read from the register, write into the register.
Right from the register.
Read operation, memory.
Right operation.
Data bus is also called a bidirectional.
Bidirectional bus, yes.
What type of bus, tell me?
Bidirectional.
Address bus is called what type of bus now?
Unidirectional.
Address bus only unidirectional, okay? Address bus, microprocessor to only for memory. So memory no need to find the microprocessor, understood no? Microprocessor there no look addresses no. Okay, microprocessor also contain the registers only, but no address no. Microprocessor contain the registers, everyone know? The B register, C register, the registers are there, but the register no address no. Okay, because the memory not to communicate the microprocessor, understood no? Microprocessor only communicate the what? Memory. So the address bus like that. Data bus is the bidirectional bus. Okay. Address bus, data bus, and one more bus is there. Okay. I told already, people know. So we have one control unit is there. Okay. Read bar, write bar, tri-state buffer. No? People remember read bar and what? Write buffer. Is a register. People remember last time? It's a digital electronics now. Is a register. Okay. In the register, you are going to perform either operation reading or writing. Why are tri-state buffer? No?
Yes.
Understand no? The read bar and what? Write bar. Tri-state buffer. Okay. Read bar and write bar. They are generally one more line also, the very popular one. CS bar. Chip selection line. CS bar. Enable pin like that. Whenever CS bar low, the entire IC enable only. In memory also an IC. Understood? No? The chipset enable or disable, who decide? CS bar. The three lines we can also call control bus. Control bus. One more bus now. Control the device. Okay. Control bus decide we are perform which operation, reading or writing. Which operation? Control line on. Understand? No? You have 8-bit register only. But in the register you are writing or reading, I don't know. Writing also, the input D flip-flop, input. Every D flip-flop input what? Tri-state buffer or not? No. You are going writing nothing but the write bar low. You are read from the flip-flop, no? Read bar what? Low. Controlling or not? Controlling lines on. Whenever you perform memory read operation, read bar low. Whenever perform memory write operation, write bar low. Depending on operation. Okay. IO also same only. IO also same story. IO also, okay. So IO read bar, IO write bar, control lines are there now. Okay. Every peripheral have control line is there now. Okay. Separate read bar, write bar. Is there? Memory read bar, write bar only. So the microprocessor to communicate the memory, the three buses compulsory only. Address bus, data bus, and what? Control bus. The three bus compulsory. Every memory device contain the address lines. The address lines are decide the depth of the what? Memory. Depth of the memory. So every memory also contain the what? Tell me. Control lines. And every memory also contain the what? Tell me. Data lines. The data lines are writing the reading or the data. The three lines are compulsory now. Every memory. Okay. Okay. Microprocessor to perform any one of the operation. Any one of the operation, it can follow 3-step procedure only. You can follow the below 3-step process. Okay. To perform any one of the operation. Okay. Out of 4 operation, anything no. Memory read operation, memory write, IO read, IO write. To perform any one of the operation, it can follow 3 steps are there only. 3 steps follow now. Step 1. For example, the memory read operation. Okay, you can take 4 operations now. You can take memory read operation. Memory read follow 3 steps only. Memory write also follow the 3 steps only. Anything follow 3 steps only actually. How memory read operation? Check it now. Step 1. So what a memory read actually? Microprocessor communicate the memory read from the register. Correct? No? Memory contain one register actually. All the registers on registers. Every register have some what? Address. Microprocessor communicate the memory read from the register. You don't understand? So what is step 1 actually? Step 1. Step 1, before microprocessor communicate the memory, microprocessor first of all should know, because the memory contains so many location, each location have some address.
Yes.
Microprocessor first of all should know exactly where to perform the operation. Okay, that's the step 1. Microprocessor first of all clarity about where to perform the read operation. So microprocessor should know the address actually. Okay, so microprocessor should know the address. The address now find out actually. Okay, so identify memory location first. To identify the memory location, microprocessor definitely should know address first. Identify the memory location. So using which lines now? With help of which lines? Address lines. With help of address lines. Okay. Now this step 1 we are using the address bus now. Yeah, address bus we are using one. Address bus. This step 1. Okay. So with help of address bus, we are find out the first location on it. Okay, which location to perform on now. For example, the understanding. Okay, see, the address always depend on hexadecimal number only. 4 zeros H2, 4 FH only. Four zeros H2. Next one, tell me 4 FH. These are addresses. Okay, 4 zeros to tell me 4 F. The address is now. Approximately we can call 64 kilobyte. Yeah, I'm mentioning hexadecimal only. So the memory range of 64 kilo is a decimal number is a 0 to 65,535. The hexadecimal number only. Hexadecimal number 4 H is a hexadecimal representation. 4 zeros to tell me 4 F. The hexadecimal representation. The hexadecimal number convert the decimal value. Decimal value is 65,535. The decimal now. The hexadecimal is a 4 Fs. 4 Fs. Okay. Hexadecimal representation perfect only. Because I told hexadecimal to binary conversion is a very simple. Correct now. For example, you want to convert the binary simple or not? No? 1 F equal to 4 ones. All 16 ones only. 4 4 are 16. Very simple or not? If 65,535 to binary conversion, difficult. Then forward. Okay. So first of all, the address find out. Okay. For example, my assumption address 2000 H hexadecimal only. Microprocessor to read from the 2000 location, the location to reading only. Okay. Then first to address bus, address decoder decode input 2000. Decode input 2000. What happened? 2000 location one selecting. Remaining locations are tell me disable. Okay. So address bus. What about step 2? So once the address selection through decoder input, once the address selecting, remaining all the outputs are disabled. Understand everyone? Through address bus, we are to this address, remaining all are the disabled. What next step? So to perform memory read operation, what next step? Read from the memory. Okay. Yeah, with read from the memory location. Using which lines now? Data lines.
Data bus.
So memory read operation, that's the read from the memory. Okay. So data bus using one. Correct. Next step 3. So whenever if you perform read operation, definitely you want the read bar should be low. Correct? No?
Yes.
Because actually what happened, tell me, the same line, you can use the reading also, you can perform on writing also. So that's why the bidirection, you wanted some control line actually. Okay. When you want to perform the read or tell me, right. That's why tri-state buffer. Understood? Bus is the same. Okay. But sometimes you want reading also, sometimes you want tell me writing also. But it's same bus only now. The same bus, two things are there only. Okay. So to generate, okay, read bar control line, control signal, okay, to generate, okay, control signal. The job done by control bus. So the job who can done? Control bus. Microprocessor control unit only. Okay. So control unit the responsibility. CU. Control unit generate the signal only now. Control unit only. So to perform memory read operation, microprocessor follow 3 steps only. It's not simple. It's not really simple only. Microprocessor to communicate the memory read operation, how many steps follow? 3. First to microprocessor responsibility to find out the memory location. Through a bus one, okay. Come here. Okay. What first step? First to find out the what memory location. What is second step? Tell me.
Read from memory.
Third step is generate the
Bus. Control bus.
memory read operation. Okay. 3 steps only. Tell me about memory write operation.
Second step.
Memory write operation. Identify the memory location. Okay.
And
Which location to perform write operation?
Yes.
Second step.
Right.
To the memory.
Right to the memory.
Write into the memory location. Memory location using what? Data line.
Data line.
Third step is a
Generate write by control signal.
Right low.
so memory read operation 3 steps only. Memory read operation also 3 steps only. Correct? So what about IO read? Okay. I already told actually the microprocessor, what is the way to communicate the memory? Same way to communicate the what? IO. No difference here. Okay, see here also everybody see also. Here also contain the decoder is there in the decoder now. Decoder. Here also contain the address now. The address bus. Exactly address bus now. Same. You also address bus now. IO address bus. IO address bus. It's a memory address bus. Memory road. IO road. 2 different roads actually. Okay, and this one. Okay. Same concept one, same thing. Okay, the same bus. No, this one called what? Same data bus, address bus. What this one tell me? Control bus. Same exactly. How microprocessor communicate the memory? Same way to IO also. Okay, tell me IO read operation. IO read nothing but to read data from the keyboard, from input device. What first step? Step 1. Identify the
Memory address.
IO location.
IO location. Yes.
IO location, not memory. Which one? IO location.
Location. Yes.
Peripheral location. Keyboard address. Keyboard address is 60. Your hardware now. Almost every laptop keyboard address 60 now. Okay. They mention manual mention now. What is keyboard address? Sensor address. Tomorrow where people how to communicate the hardware. The answer is where people should know the address of the device. That mentioned clearly in the manual one. Okay. There is to identify the keyboard peripheral address on the peripheral location using which line? Address line on the. Okay. Next is step 2. Okay. Read from the what? IO peripheral
location.
IO or peripheral location. Okay. Using which line? Data line. Generate the which one? Tell me. IO read control line only. IO read separate line only. Memory read separate line only. Same story, same steps only, but the different. Okay. Address bus, data, control bus. Step 1 address generally. Step 2 data. Step 3 is what? Control. The 3 steps follow now. 3 steps follow. So IO read. Similarly, IO write also now. IO write. What IO write? Identify the peripheral location. Identify the what? Peripheral location. Address line. Okay. Write into the right. Or send, okay, right into the peripheral location, right into the peripheral location to generate the control signals. So tomorrow, people observe now, clear? So next class we are the coming class I am going to explain clearly how to perform the memory read operation, IO read operation using assembly program, okay, assembly instructions. Okay, tomorrow write assembly program. We are read from the keyboard, we are write into the monitor. Okay, read from the memory, write into the memory. assembly instructions are there. Microprocessor internally have some instructions are those you want to study now. Okay. So whatever just now I told the very basic, very foundation. Okay, there are people understand. Okay, clear or no? So this is a overall what are the picture? No, is a beautiful one. Okay, this picture see everyone know. Microcomputer structure. Okay, so computer structure you mainly can see the meaning of structure. You can see the address bus, data bus, control bus. These are structure clearly. And operation. So I told now microprocessor perform how many operation? Four operation. So they explain clearly in the diagram now. You understood now clear? Hello. So next you can see the type of architectures also. Okay.
So CS bar is to enable the device, right?
Which one?
CS bar, chip select.
Oh yes, CS bar. So actually, what is the purpose of the CS bar? Actually, practically not only one memory IC, multiple memory ICs are available on it. Memory IC 1, 2, 3, multiple. Okay, number of so many ICs are there. So whenever you have multiple ICs are there, every IC have one CS bar. So whenever microprocessor to communicate which IC, that chip selection should be what? Low. Okay, before the chip selection line also part of control line only. Okay, then before read bar compressor this should be enabled. Compressor no. Okay, because multiple ICs are there no. Starting compressor which one enable? CS bar, then read bar. To perform read bar, write bar, first of all you want to enable which one? CS bar. CS bar, read bar. Otherwise CS bar, write bar. CS bar compressor no. So why CS bar? Because multiple ICs are there. Okay, which IC to communicate no? They decide now the IC1, IC2 or IC3 which one to decide now to communicate. So where people know the RAM no multiple no the ICs no multiple RAMs you can interface. Okay, so
Yes.
every not only for RAM only no, the peripherals also CS bar is there. So every peripheral have one device controller, audio controller, USB controller, Wi-Fi controller, network controller. So many chips are there. No? Everyone have one CS bar line in there. Okay, the communication beginning moment this one low. Okay, once closed and every time CS bar compulsory now.